In this lecture, we will discuss a stack implementation using linked representation. Previous lecture we had seen how to uh, create a data structure stack using array representation. Now this is to implement a stack using linked representation. The difference there, we had created a variable stack top and it was integer. Now here the stack top should be a node with two fields, one for element and one more for the next address. So we have already come across this configuration while discussing a linked list in module 1. uh, Node has two fields, one element field and one more is the next field, which points to the address of the next node, wherein you will be having the field value will be the next address will be stored in that. So this is actually a linked a list architecture. So here same, the number of methods what you have here happens to be same as if as you had it in array representation. So you have one constructor, one destructor, empty, size, top, pop and push. So push is easy. We will talk about push first, then we will talk about top, then we will talk about empty and size are similar. This has to be, you call this empty, followed by creating an object of a linked stack. This will be returning 0. Now let's begin with, so private data you have two. This is your stack top, which will be used because stack top is actually the node which should be modified based on push or pop instruction. Okay, now stack size, the capacity, number of elements what you have in the stack, but if you want to display, then this is actually the variable used for it. Okay, now let's go back to this slide, and this is, rather than stack, we will call this as linked stack, and t is int and s we have. So once we create an instruction something like this, then the configuration set will be this. So it has to create a stack with null in the sense this node pointer to a node is pointing to none of the nodes. So stack top should be set to null. When we create an object s of the class linked stack, it should be linked stack. I have represented it as stack in general. Okay, so let's see whether this is happening, and when this instruction is called, which method will be called. Okay, so when we go back here, so you have the constructor defined here. This is the constructor defined. So you have created an object with the no argument. So you have stack just is s of 10 is not addressed. So default constructor with argument 10, initial capacity 10 will be called. So this function is executed and it will create stack top. So stack top is equal to null implies this is what the pictorial representation looks like. Stack top is null. So you have a null pointer set. Okay, and also it will create stack size is equal to 0 because you don't have any element now. None of the element is pushed onto this stack. It's empty. Hence, when this instruction is executed, this function is called, and initially it is going to create a capacity of 10 and the stack size is equal to 0, and stack top will be configured, it will be a null pointer. Okay, now let's look at what happens when push instruction is executed on to this configuration. Okay, now definitely the stack top, this node pointer has to be modified, and in you have to create a new node. There in that field, the first field element should go, and the next field of this node has to be connected to the previous stack top. That's what we need to do, and let us see whether this configuration is happening when we are calling the function push and we are inserting an element 10. Okay, so you are here is dot push. Let's see what happens now, which function is called. So here out of this function is called. So okay, the element value is 10 now. So push of 10. So what happens? Stack top is equal to new chain node. So we have discussed chain node. Chain node we have three ways to configure: chain node with no argument, chain node with one argument, and chain node with two argument. So here we are using chain node with two argument. Chain node, first argument is element, okay, second argument is stack top. So what happens when you execute this? The new node will be equal to the previous node what you have, its field. The new node's field will be occupied, or it will be linked to the old stack top. I repeat, the new stack top will be created, a node with a new stack top will be created, and its element will be 10, and its address will be linked to the old stack top, and that created new stack top is named as stack top. So we will look at, this is what it is doing. Okay, I repeat, you have a stack top which is created as null. Now create a new node, fill the element 10 because of this, and the next field link it to the previous stack top, and this you call it as a new stack top. And that's what is happening when you use s dot push. That is how the push instruction over here works. Hope this is clear. Now what happens if I execute an instruction after this s dot top? Okay, s dot top, you are supposed to print 10 because the element at the position stack top of element position you have 10. So how it will be printed? So let's go to top function. So it will check if stack size is equal to 0. So what happens after push? After push you do that, and also the stack size is incremented. So earlier stack size was 0, now it becomes 1 when you use push instruction, saying that one element you have in the stack. Now you have invoked top. You have if stack size is equal to 0. So stack size is equal to 0. Is it the case? No, you have one stack size now. One element is inserted. So this condition is false, so this is true. Return stack top. Okay, so what is stack top? Stack top is this node, its element field has a 10 value, and this should be returned. So return 10. That's what we have here. Return stack top element. So 10 will be returned back. Okay, that's the top element now. Simple. Okay, now let's see what happens when I use s dot pop. So this is a bit interesting. So what it has to do is, so this is what it will do. It will create one new node. Okay, it creates a new node in the pop function. You have to create a new node, and that new node or that next node should point to the next field of the stack top. Okay, stack top's next field it has to point. Suppose if you are having only two elements, okay, and then you have to delete this previous node and name this next node as stack top. That is what you are supposed to do only if you're having two elements. Let us see whether it's happening. Okay, so we go back to pop function. Okay, so pop function is addressed here. So you check, is stack size equal to 0? What happens if stack size is equal to 0? Stack size is equal to 0, then you don't have any element in the stack, so stack is empty. Okay, that needs to be checked. So you have this condition. If not, so first you create a node, next node, and make it point where stack top of next points. Okay, so stack top of next is pointing to this node, and next node is pointing to the same node. Fine. After that, I want the stack top, which is this node, has to be deleted. So to delete this node, we will be using delete instruction. Creating, we will use new instruction. So this node will be destroyed now, but the link is established between these two. Okay, so this is destroyed. So that's what is happening here. Delete the stack, and later name stack top as the next node. So this is your next node. Name it as stack top. That's what is happening. So this is a null vector now. Now we don't have any element, and also so stack size should be decremented by 1. So previously you had one element, now this becomes 0, so you don't have any element. This is how the pop function works. Okay, the last instruction what you have here is a destructor function. This function destructor will be called once everything, all the functions whatever you're gonna use for the stack will be killed. Okay, this is used for killing the object. This is to destroy all the stuffs, variables, functions which you have initially created. If it needs to be destroyed, then you will be using. For example, let's assume that we had made some 5 push operations. After that, 5 elements are there in the stack. Now I want to delete every element once the program gets terminated. So in that case, this function will be called, this function you call it as a destructor will be called, and it is exactly equal to the definition of pop instruction. But the only change is it is not going to destroy one element, instead it is going to destroy every element present in the list till the stack top reaches null. So it checks stack top, is it null? So if it's not null, then the next node point to the stack top's next node, and you're going to delete the stack top. Then again stack top will be pushed to next node, and you repeat this process till stack top is not equal to null. So when it is equal to null, then you can definitely say that you don't have any element present in the list. So this is how the linked stack destroy function or destructor works. That's how this is about the stack. Fine. Any doubt you can call me, you can message me, no problem. Time being, it's fair enough.